Hello everyone, today we're talking about our product work, which name is Orbital Guardian, and the main purpose of our product is to collect the space debris which is located in the geostationary orbit and mitigate the pivotal problem in the space as extensive number of space debris.
So, as my teammate emphasized, our project, which collects the space debris that's located in the geostationary orbit, is crucial for the future of the space exploration. So often uncontrolled space debris threatens the satellites that are located on the orbit of the Earth, and it can cause the costly damages to the space companies. So if we left this problem unchecked and uncontrolled, the cascade effect can lead to an overcrowded orbit by the debris, so blocking the humanity's ability to surveil the space. So by focusing on this problem right now, we can ensure the sustainable development of the space exploration in the bright future.
After ascending to geostationary orbit, our artificial intelligence sensors come into action and locate the nearest space debris. In simple terms, Orbital Guardian will chase and capture the debris. As our spacecraft approaches, the space debris collides with the front structure of the bag, where it enters and accumulates in a layer of aerogel. The debris collection mechanism will be repeated until sensors located above the aerogel layer indicate that the layer and the bag itself are 90% filled with debris. Then Orbital Guardian changes the side of the flight and begins collecting space debris with the bag on the opposite side. When both sides are filled, using a solar sail, the spacecraft will descend to a waste recycling plant directly in orbit. For a full understanding of the Orbital Guardian's operation, we will show you the entire principle of capture with a bag on a built model. The law of movement on the surface is reproduced thanks to mechanism wheels. The Pixie camera, which functions as sensors on the original device, immediately starts working and finds the nearest object, and our artificial intelligence signals whether the object is debris or an active device. As you will see, our device can automatically find the location of debris and capture it. The ball that plays the role of debris remains stationary according to this frame of reference. Due to this, the capture of debris will be accomplished with the ion engine, whose role is played by mechanism wheels. By increasing the electric field voltage to 10 kV, using a high voltage power supply PHYWE with a digital display, molecules on the metallic part of the positive electrode, to its design, become ionized and move toward the negative electrode, generating thrust. We validated the effectiveness of this technology through a candle experiment. When the power supply was turned on, the flame of the candle deflected under the influence of the particle flow, confirming the presence of the generated thrust. For the purpose of detecting space debris, we have developed artificial intelligence using the Python programming language. As a model, we chose the neural network YOLO, as it surpasses many other algorithms in efficiency in detecting objects. Object detection is the process in which bodies are located on an image or in a frame, and their exact coordinates are determined using bounding boxes. Our initial task was to use a model that takes an image as an input and outputs the boundaries of the object in the pixel coordinate system. For this, we prepared a dataset from the Kaggle platform in the required format. Then, bounding boxes, that is, frames, are written in the format xmin, xmax, ymin, ymax, but for using our model, we need the format xcenter, ycenter, width, height. Thus, we prepare our dataset in the required format for YOLO. Our AI operates as follows. As you may notice, initially an image or frame with space debris is fed in. The neural network analyzes the image and highlights the area containing space debris. These numbers 0.81, 0.85 represent the AI's confidence up to 1. According to the provided AI graph, our model demonstrates a high level of precision at increased confidence values, indicating its reliability in confident predictions. Moreover, we have developed a model of the device, which was almost entirely printed on a 3D printer. For its creation, we modeled 3D objects according to precise drawings and scales in the Blender application. For the actual printing of these models, we used PLA plastic on a Prusa 3D printer. During the research process, we gathered information on the most dangerous types of space debris found in geostationary orbit. In studying this issue, we analyzed the data and, based on the collected information on an alternative for our project, were able to identify the best methods for eliminating space debris in orbit. Having confirmed the uniqueness of our spacecraft, we assembled an ion engine using the materials available to us and tested its operating principle under school conditions. Additionally, with the help of LEGO EV3, we created the operation of the Orbital Guardian in the form of a model, simulating the spacecraft's operation in orbit and space conditions, and developed a program for capturing debris with this device. We hope that by conducting this research work, we have made at least a small but significant contribution towards solving such a large-scale problem.